3 deals with solving trigonometric equations. And solving a trig equation is very similar to solving any other type of equation you've ever done throughout your entire math career. So we're going to look at a few examples without any trig signs in them, and then we will get to some that do have them. So in solving this first equation here, 5 times x plus 8 minus 3 equals 22, we would have to add 3 to begin with to get 5 times x plus 8 equals 19. And that's not correct because 22 plus 3 is 25. So now you would then divide by 5 and you would have x plus 8 equals 5. Finally, getting x by itself, subtract 8 and x would equal a negative 3, and then you have it solved. Now another option that you could have in doing this problem would be to take this whole side and simplify it first by taking the 5 times both those two things and then combining it with the negative 3 and then doing all of these same things that you did here, and you would still get to x equals a negative 3. Another type of equation that you've seen would be a quadratic equation, and in this case if you have a quadratic equation you can either use the quadratic formula or you can try to factor it. In this case, are there factors of 5 that add up to 6? That would be a big yes, because 5 times 1 is 5, and 5 plus 1 is 6, so you can factor to x plus 1 and x plus 5, and that equals 0. And so then, since these are the factors, x would equal a negative 1, and x would equal negative 5. And then that equation would be solved as well. So then, moving on to a problem where you have this type of thing. Now we're dealing with a trig equation. There are two ways that they're going to ask you to solve equations like this. One way is in general form. And when they ask you to solve in general form, then you have to list all possible angles. And not just those between 0 and 360. So then we're talking about, so if you get an answer of, say, this angle right here, which is 30 degrees, you possibly could have another one over here at 150 degrees, depending on what you have for answers. But just so you know that, it's not only this 30-degree angle, it would also be this angle that's a negative 330. And it would also be this positive angle that would go from here to there, which is 390. And then the angle that would go around twice, and so on and so forth. And so there are infinite number of angles that are listed there. So if it was just talking about this one particular angle and not any other ones, you would say something along the lines, if it was a 30-degree angle, and then you would have to say plus 360n, where n is some integer both positive and negative. So you don't have to say plus and minus 360n, you can just say plus 360n, because that takes going this direction around the circle or that one. And I know that kind of sounds confusing, but as we go through some of these examples, maybe it will clear up some. So generally speaking, in this form here, in order to get x by itself, we have to get rid of cosine. And to get rid of cosine, you have to perform the inverse operation, which means that x equals inverse cosine of the square root of 3 over 2. And now you have to come up with where is cosine the square root of 3 over 2 in your unit circle? Is it here, there, or there? It would be this one here, which is 30 degrees. So we know that x equals 30 degrees. Now, where else is cosine this same answer? That would be also right there, which is 330 degrees, or you could say it's a negative 30 degrees. however you want to say that. Easiest thing would be to say it's a negative 30. So now we know that x equals at 30 degrees, both plus and minus. And then, because this is going to happen when you go from there to there, you would be adding 360 n to it. And if you take this angle and add 360, that would be that one. So we're okay with everything then, and we have all of the angles listed. The other way that they can ask you to solve that is through an interval. And typically the interval they're going to give you is from 0 to 2 pi. And one of them they'll put a parenthesis, the other one they'll give you a bracket, which then means that 0 is less than x is less than or equal to 2 pi. You would do the same thing, and so you still have the inverse cosine of the square root of 3 over 2 and x equals. And so now we're only talking about the angles from here to there, which we would have this 30-degree angle, and we would have that one, so we would say 30 degrees and 360 degrees. Not 360, 330. It's just a condensed version of our general form, because we're only dealing with the angles we need to deal with. If they tell you in the interval, actually for this one here, because they say it's from 0 to 2 pi, you should write your answer in terms of what they say for the interval. So we shouldn't use 330 and 330. Instead, we should say pi over 6 and 11 pi over 6. So that's one example of solving an equation. Now let's look at a second one. Here we have secant of x, cosecant of x equals 2 cosecant of x. So, and trying to solve this, you would have to get everything to one side first. And now, because we have it all on one side and we have a bunch of different things, we should probably try to factor it. So we can take a cosecant of x out, and we would have secant of x minus 2 equals 0. Now, like the problem we factored before, we would use our zero product property and say cosecant of x equals 0 and secant of x minus 2 equals 0. And then with this one on the left here, x would equal, or actually let's change that. Because cosecant is 1 over sine of x equals 0, then that means sine of x is, since that's a reciprocal, we would have to take the reciprocal of that, and the reciprocal of 0 is undefined. And then we'll finish this part of it. Is there a place where sine of x is undefined? No. So there is no answer here. Now if we look at our other one, taking this and putting it as secant of x equals 2, and then we would take that and say it's 1 over cosine of x equals 2, and so then that means cosine of x equals 1/2, and then because cosine of x equals 1/2, x will equal the inverse cosine of 1/2. And so now, where is cosine 1/2? General form, then we would say that cosine is, it's right here is 1/2, and it's right there is 1/2, which is at pi over 3 and 5 pi over 3. And then you can say plus 2 pi n and plus 2 pi n. And if you want to do it in the angular measure, it would be 60 degrees plus 360n and 300 degrees plus 360n. And since it's this angle and that angle, we could also just make it into one statement and put plus and minus 60. And if we were given a specific interval, say between 0 and 360 degrees, then we would only say 60 degrees and 300 degrees. And so then those are the only two angles, if going with the interval, that we could put in for x. Now you also have to understand that it doesn't necessarily have to be x for your variable. They could put theta here for all of them. Still the same problem. They could put alpha. They could put beta. You still do them all the same way. It's just another variable, just like x, y, and z. Okay, looking at our last example for today. Solving this equation for x, the first thing you'd want to do is subtract 1. So you have the square root of 2 sine of x equals negative 1. And then dividing by the square root of 2, you'd have sine of x equals, and you shouldn't have the square root of 2 in the denominator, so that would become a negative square root of 2 over 2. Then getting rid of sine would be inverse sine of x equals a negative square root of 2 over 2. Now you have to refer to your circle, and where is sine a negative square root of 2 over 2? That would be down here in this quadrant and in that quadrant, because sine is your y value. This angle from there to there is 5 pi over 4, and the angle from here to there is 7 pi over 4. And so if we're going to write our answers in general form, it would be 5 pi over 4 plus 2 pi n and 7 pi over 4 plus 2 pi n. If you went in as an angle, those would be 225 degrees plus 360 n and 315 degrees plus 360 n. And if they gave you an interval from 0 to 2 pi, then you would only say 5 pi over 4 and 7 pi over 4. Now, a way that you can check any of these answers throughout all of these problems would be to graph the things. Enter this as one equation in your calculator, enter this side as the other equation, so call this one y1, this one y2, and then graph them, and you would get some things, and then they would intersect because of what you have 0, which would be right here, and then that other one would be some type of a wave going like this, and the places where it crosses, they intersect, would be at 5 pi over 4 and 7 pi over 4. Now, they aren't going to give you those answers on your calculator. There's going to be some decimal equivalents of them, but then you should be able to convert them. And we'll talk about that a little bit tomorrow in class. But understand that when you do this on a test, all of this fine work has to be there for you to get full credit, because anyone can just put it into a calculator and get an answer, and that's not what we're trying to see. I want to see if you can actually solve it algebraically. So we will see you tomorrow, and you can start working on that assignment tonight and maybe have a few questions for me when you come tomorrow.